Hey everyone, welcome back to ML Works. In this video, we'll be discussing a very interesting topic called visual grounding. So this is a process of identifying an object or a region in an image based on the natural language. Okay, so this requires understanding of the image, certain parts of the image by the computer based on the language description that we give, natural language sentence, whatever, right, that we give to the input of the model. Okay, so it has to understand that phrase and then locate those objects in the image. So we'll understand that. So for that, what we'll do, right, to complete this whole task, we'll be using something called as RAG with Docling. Docling is, as I said in one of the previous videos, that it is a library for parsing documents. So we'll use that. So the whole flow will look like this. Okay, so consider you have documents and you will be parsing it in such a way that it is capturing the page as images. Okay, and also we'll have the content part of it, like the text content of the document. Okay, so we'll be turning that into an embeddings using the sentence transformers library, which is we'll use this specific model from sentence transformer, which is all mini LM. Okay, and then we'll be storing those embeddings into vector store, and then vector store will turn into retriever for RAG. Okay, and then whatever the input questions that we have, will be sending it to the specific retriever along with the LLM to understand what is the question and what is the corresponding answer to be fetched from the retriever. Once that is done, we'll be getting the results in such a way that it will point out the location. Okay, so for a specific content, what was the corresponding page and what exactly the location or the paragraph where the answer is coming from. Okay, so finally we'll get the results. That's what I'm saying. So we'll get the output answer and the image, the location of the answer in which the location of the answer in the image. Yeah. So that is nothing but your context from which the answer is picked from. Okay. So this is what we'll do in this specific video. This is going to be a little long video because we have to go through all this process. So let's understand, right? First thing, we have to install the packages which are like quite mandatory here. We'll be using LangChain Docling, LangChain Core, and then LangChain Hugging Face, LangChain Melvis. Okay, and this is LangChain, and then for plotting we'll use matplotlib. For loading the environment variables, we'll use python-.env. So Docling is the integration of Docling with LangChain. LangChain Core is for LangChain, managing various aspects of LangChain. And then Hugging Face is nothing but for model management. And Melvis is for vector store. And LangChain is for the whole management of this whole process, right? So these are the packages. So this will take some time to install. I have already installed it, so it should not take much time for me. So it's already done. So let me close this. So once the package installed, what we'll do is we'll import the packages. First is OS, then path for path management for creating temporary directories. And then we'll load the environment from here, and then this is prompt template for creating the prompt, which is taken from LangChain Core, and then how you want to export. Okay, so for that we'll use LangChain Docling.loader export type. So here, if you see, I have load.env. Okay, so if you see here, I have an env file which contains the Hugging Face token. So this will load the Hugging Face token for me. And this is for setting the parameter tokenize as parallelism. Okay, so this is done. Let's import everything. Now, so since we are creating a RAG is nothing but you have bunch of documents and turn that into vectors and load it, act as a retriever and load the content required based on the input query. Now for this scenario or specific video, right, we'll just have one document instead of like multiple list of documents. We'll have only one element in the list, and this is nothing but your Docling technical report. So let me just go here. So this is the Docling technical report, and this is the content. Okay, so now so we have given the path from where it has to load the document. Okay, next we initialize the model that we have to use for embeddings and then for text generation. So here we have sentence transformers, all mini LM L6 V2 version embedding model, and then we are using minstrel model. So to use this model, okay, there are like some rate limiting, so you can use the tokenizer, not tokenizer, the tokens to use it. Okay, so it's better to have the token available and then use minstrel 7 billion parameter model. So this is, okay, let me run this also once, and this is, let's run this. So we have initialized the model. Okay, then we are creating the prompt. Okay, so prompt is nothing but what you will be sending to the text generation model, okay, such that it will fetch the correct answer for you. Okay, so the question is, what are the main model AI models used in Docling? Okay, and the prompt is prompt template, which is taken from LangChain, I guess. Yeah, LangChain core prompts prompt template. So here we are creating the template where the context information is below, and we'll pass the context, which is the content from the document. Okay, and given the context information and not the prior knowledge, answer the query. So the query is nothing but the questions that we are going to send. Okay, so this is that. So this is the our whole prompt that is required for sending it to the LLM. Now these are certain parameters. Here top K is the number of documents that you want to retrieve from the retriever based on the understanding of this query. Okay, and then Melvis URI is nothing but where you want to store your documents as in the vector store. Okay, this is the path that we are creating, document docling.db. So let me run this as well. I guess I didn't run this one. Run this and then run this. So this is where everything will get stored in the vector DB. And next is which we saw in the previous video of basic Docling, where we are trying to convert your document, PDF document, into some text content. So here what we do, right, along with that, okay, we are also ensuring that we are generating the page images. So each page will be considered as an image also. Okay, and this is the image scale. Okay, this is some kind of a parameter, right, for it will, the way the images is generated in the backend from the PDF. So this is the document converter, and this will contain the text. It will generate the text and also the images, store it as an image. So in the backend, what will happen? It store it as an image in this it will store it in the base 64 format in the backend, the specific images or the pages. Okay, so let me run this converter. We are just initializing in this place. We are not doing anything else. So this is the PDF format options. Okay, just to understand it, this is the module that has been used for formatting the PDF. Okay, so next is we are taking the source document, which is technical Docling technical report, and applying converter from Docling and storing it as JSON. Okay, so let me run this. So I'll also show, right, what is happening here. Doc store. So this will take some time because it has to understand each page from the document, PDF document, and then store it as a JSON with all the information exactly how it is present. So let us wait for a few seconds. It's 20 seconds. It should take less than, yeah, this is 24 seconds. Yeah. So doc store. So if you see, this is the hash, binary hash, okay, for that specific document, and this is the JSON. Okay, now what we can do is, if you want to look into this one, let me just open this. I think this will open it, but this is, since a large document, right, because there is images and all these details are present, so this may take some time actually. Okay, let me print it also here. Right? I'm not sure if this will print or not. Yeah, so this is a very big kind of a block. Okay, so let's just understand this one. The schema name is Docling document, and then the name of the image, name of the PDF is this one, and then we have binary hash file name, and this is furniture. I'm not sure what it means. Okay, the content layer is furniture. So this is body, and then there is number of pages is 9 total, I guess. Let me scroll this element. Yeah, the total number of pages is 9. If I go here, 3 pages, totally 9 pages here. So here if you see, there are like each page is stored as an image. Okay, and this is for PNG image base 64. This is the image detail. Okay, after transforming it into bytes. Okay, base 64 format. Okay, so this is the whole details, right, regarding the document. Now let me just close this one. Yeah, not required anymore. So what we'll do next is we'll turn this document that we have here. Okay, doc store, not even doc store. So this is separate thing. Doc store is separate thing. We don't have to think about it right now. So here what we do is we use something called as Docling loader, okay, from LangChain, and we'll be applying that converter, right, such that it reads the PDF and turns it into text. And the text is also, we want it in such a way that it is able to chunk it, okay, such that there is some limit that the embedding model will handle. Okay, so we want to chunk it. So we use something called as hybrid chunker, and then we pass the tokenizer, which is embedding model again, which is all mini LM, okay, from sentence transformer. So this will generate the docs, okay, so chunked documents, I mean. So let us run this one, and next. So yeah, what will happen, right? This will generate the chunked document, and this is how it will look like. So we'll be iterating through the docs, okay, and it contains something called as page content for each page, and then we'll be just looking at the token. What is the token length for each page content, right? So we'll be splitting it based on the spaces and get the length of the token length for that specific page. Not even page, this is purely docs actually. Okay, this doesn't refer to the whole page of the specific technical report. This is kind of a page content for this one after chunking, right, that you get. So that is that. And if you see here, so let me iterate through this one also. Yeah, this is done. So this is the page content, and this is the technical doc report version 1, and this is the author name. If I just go here, you will see those details. Technical doc report version 1, the author name. Okay, so next is the abstract. So the thing is, if you see this whole thing, right, it is able to understand the context and create a chunk which is appropriate. It's not like it is combining these two and turning it into one chunk. Okay, it is able to split or chunk it in such a way that it is quite meaningful. Okay, so that's very important. This is happening because of the hybrid chunker that we have used here. Okay, now this is chunking is done. Now what we do is, now comes the part of here loading documents to Melvis. So we have Melvis data store, which is vector store. What we do is we store the embeddings of these documents that we have and store it into Melvis vector store. So this is the documents, and which is nothing but these docs that we got here. Okay, chunked documents, and we are using an embedding model, which is nothing but all many LM, and the name of the vector store database in this case for this specific scenario is Docling_demo, and we are storing Melvis URI is where we created the DB, right? Melvis DB. It is that specific location. The index type is flat because we want to. This is the technique for how we are going to search the document. Okay, so this is the index type we are using for that, and we are trying to overwrite this one, drop old. Okay, if there is already Docling demo, we'll be overwriting that. So let us run this one. So this will also, it has to create embeddings for each document. So it took 5.5 seconds. The point is also, right, I am also using GPU in the backend, so that is there. Okay, and this is for ingestion of the documents into the vector store. Now what we do is we try to create the rack from out of it. Now what we do, the vector store is present, and we turn that into as retriever using LangChain. Okay, So this is the argument for this one, and like vector store dot as retriever, and the search is top k, which is 3, which we have already set in the earlier cells. Okay, and then we use Hugging Face endpoint, which is the Gen AI model, which is Minstrel, Hugging Face token, and the task is text generation. Okay, this is the LLM and this is the retriever. And then we have something called as a clip text. This is like how much text you want to generate for your query, right? For us, whatever query you have, you want to generate the solution, and that solution should have some upper threshold of tokens. Okay, here we are setting it by default as 100. Okay, so this is that. And then what we do here is next create a retriever chain on the documents. So what we do is we generate what you get is so this is like all these two are combined together. Okay, what we do is we create a retriever chain, okay, which will take in the prompt and then LLM that you want to use, and then this will understand, right? Overall, what it will do, right? It will understand your documents and the model you have to use for understanding the input query. Okay, so we are creating kind of a object here. Okay, rack chain object, which will contain your prompt along with your LLM model and all the documents that you have. Okay, so it will use all those information. And then what we do is rack chain dot invoke. Okay, and we pass in our input and the questions that we had earlier, which was what is the main model, AI model used in Docling. That was our question. Okay, so we'll get the response here, and then we are clipping the response and generating, and 250 tokens will be used. 250 is the length of the results that we'll get. Okay, so here this is the clipped answer, and this is the question followed by the answer. Which are the main AI models in Docling? And the Gen AI model, which is LLM, was able to understand it, and it was able to say that it uses layout analysis model and table former. Okay, so layout analysis model is an accurate object detector for page elements, and while table transformer is a state-of-the-art table structure recognition model. Both models are available. It was about to say something, but since we have upper threshold, it stopped. Okay, so this is the answer. Now, if you look at the dictionary, which we got the response dictionary, so this has the input. Okay, this has the response. Okay, and we also have the context. So this is what I was talking about when I was showing this diagram here. So you'll get the answer, okay, and then you'll get the what output context. Okay, and this is nothing but the details of the images that is present inside the result, right? So let me go here again. So if you see here, you will see since we have what given the top k as 3, okay, the context, it looked into 3 different context. Okay, so first, so this is the dictionary for that, and you will see there is page number 3. Okay, and then bounding box is present, and then if you see here, it gives the all the right, left, and bottom, top coordinates, and then it is giving the heading, okay, 3.8 AI model, and then origin, PDF, the binary hash, file name. Okay, I'm not sure what PK refers to. The source is this document, and the page content. Okay, this is the page content, and if you see here, the page content, AI models. As part of Docling, we initially released 2 highly capable AI models to open source community. Okay, and which have been developed and published directly by our team. The first one is the layout analysis model and accurate object detector of our page elements. The second is the table transformer, okay, which is a state-of-the-art recognition model, table structure recognition model. We provide the pre-trained weights in the Hugging Face and the separate packages. Also, okay, so the whole thing is present, right? It is able to understand your question, and it was able to generate the answer from this specific context. Okay, and similarly there are other contexts that is available. Okay, we can look at that later. So this is the respective response dictionary, and what we do, right, from this information, okay, all this information, what we do is we try to locate the image or the point where this result is taken from, okay, where this response comes from. So for this, there is a lot of processing is done. Okay, we iterate through the context, and then we get the page content, okay, which is the text, and this is the source, okay, and then we have doc meta.model validate, and we pass our model metadata, okay, DL meta, and then we'll be loading the full Docling document from the doc store. So we are loading the whole document, and then what we do is we iterate through the doc items, which is nothing but we iterate through all the content of this DL meta JSON, right? We iterate through that and get the first province item, and then look at if there is any image or not. If there is an image, then we go ahead and create that image and create a bounding box for that image, right, based on the coordinates that we got here, okay, the coordinates that we get here. So if you see, these are the bounding box coordinates, and we try to utilize that and create the bounding box for the solution that we have, the answer we have. Okay, so this is where we create the rectangular box on the PDF, and then we iterate page by image by page. Okay, so we show that through the matplotlib. So this was as I spoke about this one, this is the first one, probably with a high probability. Okay, for the question, what is the question was? The question was, what are the main AI models? So it was able to give you this information. It uses layout analysis model, and then there is table former model, okay, and it is able to locate in the image. Okay, this is the part of the image from where this has been picked up. As part of Docling, we initially released two highly capable AI models as to the open source community and the layout analysis model. So it has able to detect that specific location or the region where the specific content is present. Okay, so this is for the first context, and then comes the second context. Okay, so let me just directly go to the highlighted version. So Docling implements linear pipeline. Okay, so if you see here, somewhere here, such as layout and table structures, it talks about the model. Okay, so if I see wherever it is right here, which retrieves the programmatic text tokens, and then standard model pipeline applies. Okay, so this is the AI model. It is talking about the sequence of AI models. Okay, so it is the second best reference that it got for the question, what are the main AI models, right? So it is able to generate this specific context, and it is able to highlight that part. And the next is the third reference, which is being made here. So here, if you see, it talks about several more models that needs to be used, such as figure classifier model, an equation recognition model, a code recognition model, and more. So these are like some future work where it is something relevant, right? If you see, understand that based on the question, this is quite kind of a relevant answer that is possible. Okay, they're talking about models. Okay, so this is the third reference or the context from where the solution was picked. So what we have understood, we are able to create a RAG system where we are able to get the response, okay, text response, along with the information regarding from where this text response belongs to in the image or the document. Okay, so we are able to create the bounding box for that also. Okay, so this is quite good actually. Okay, this has various application if you think about, right, where the car is present in the image. Okay, so if you talk about this specific scenario, right, where the CAPTCHA is done, right, where you want to verify whether you are a human or not, you want to identify the specific location. Okay, that could be one of the application, right, for this one. So yeah, so with this I'll conclude this video, and thank you for watching.